All right, good morning, everyone. This is classwork 16 on compound interest. Our objective is that students will be able to compute values of future investments with compounding interest rates. And I'm going to give you a new formula, and then we're going to go over some examples. Okay, so let's first talk about what a compound interest means. So when we have compound interest, that means that there's a compounding period. So the compounding period is how often the interest is compounded. So we've done problems where someone had interest in a savings account and maybe you got a % of interest monthly or a % of interest yearly. But a compounding period is going to be how often interest is compounded. And in these cases, it's going to be within 1 year. So how often interest is compounded. So we have this n value now. So we've seen f, we've seen p, we've seen r, we've seen t, right? So the new variable is n. N is going to be the number of compounding periods in a year. And we'll go over some examples so you can see what that means. And this is only in 1 year. So what the point of this formula is if we have an interest rate per year, but we have a compounding period that is less than a year. So if our interest is compounding more often than every year, then we use this formula, okay? So in this case, T is always going to be time in years, okay? So T always is going to be years when we're using compound interest. Now, everything else is going to be the exact same as it was before. So we know that R is our rate, and we always express this as a decimal. So we'll still be converting percentages to decimal. And we know that P is our initial value or initial deposit. And then F, of course, is our final value or our value after T years. So what we're going to be doing is using some word problems. We're going to be determining what is the compounding period. So then what is N, what is R, what is P? And then we'll be using a time T to compute the value after some time. Okay, so this is our new formula for today. And then we'll have another new formula tomorrow as well, or in our next lesson. Okay, so my first example is number 1. Dwight has $4,000 that he wants to invest in a retirement account. The account earns 8% per year, compounded every 3 months. Write a formula to model how much money Dwight will have at the end of each year. How much money will Dwight have in his retirement account after 12 years? All right, so we've got a lot going on here, right? First, let's underline what they want us to do. So they want us to write a formula. And then we want to compute how much money will be in the account after 12 years. Okay, so we know when we're writing the formula, we want to circle all of our numbers, right? So it says $4,000, 8% per year, every 3 months, and 12 years will come later, right? So very similar to what we were doing last week. So if you haven't done last week, go do those assignments first because they'll help you with these, okay? So we know then that if we have $4,000 initially, that's going to be my P value, right? Because my initial value is P. And let's recall my formula is F equals P times 1 plus R divided by N, all to the N times T. Okay. Oops, there you go. So we've got my p-value, and then I've got a percent right here, which we know should be my r value. But r has to always be a decimal, right? So if I have a percentage, I'm going to say 8 divided by 100 to get my decimal, which is 0.08 now. Okay. Now, we've got my p and we've got my r. Now, the new part is the n. The n value, remember, is the number of compounding periods in 1 year. So first we're going to figure out what is the compounding period. So the problem states the account earns 8% per year compounded every 3 months. Okay, so that means my compounding period is 3 months. Now, if my compounding period is 3 months, then n will be the number of times 3 months. The number of times we can fit 3 months into 1 year. Okay? So if we think, okay, a year has 12 months, then I'm really going to do 12 months divided by 3 months will be 12 divided by 3 is 4, and my months will cancel out. So my n equals 4. So let's write our formula. So I have, let me write it in a different color, F equals my p-value, we knew was 4,000, 1 plus r, which was 0.08, over n. My n value we said is 4, all to the 4, which is my n value, times t. Okay? So this is my formula. I've got my initial value, my percent rate, and my n, which is the number of times the compounding period will go into a year. So a lot of times I might see a 3 in the n spot, and that would be wrong, right? We're taking the 3 and we're going to put that in the denominator. We're always going to be taking 12 months and dividing that by the compounding period if the compounding period is in months, right? To get 4. So I never want to see a 3 here if I'm saying compounding is every 3 months. Okay. So now we've done the write a formula part. Now we can say how much money will Dwight have in his retirement account after 12 years. Okay, so 12 years. 12 we know in years is going to be my t value. All t values are in years for compound interest. Okay, so then I can substitute in 12 for t. So if t equals 12, then I'm going to have f equals 4,000 times 1 plus 0.08 over 4 to the 4 times 12. Okay, so now we have a number of different steps here. So what I like to do is I'm going to take out my calculator and I'm going to start with these numbers inside. So inside the parentheses, because that's how my order of operations goes, right? So I have to do division before addition. So I'm going to say 0.08 divided by 4 is 0.02. So now I'll have, and I'm going to go over here, F equals 4,000 times 1 plus 0.02 to the 4 times 12. Okay, so then F equals 4,000 times 1 plus 0.02 will be 1.02. And we can do 4 times 12. We know that is 48. Okay, so now I know I have to do exponents first. So I'll do 1.02. And then I use x to the y to do the exponent to the 48th power. That gives me 2.58. So I'll get 4,000 times 2.587, which will be equal to, I'm going to multiply this by 4,000 now, 10,348.28. And I'm rounding to 2 decimal places because we're using money, so that would be $10,348.28, right? Okay, so that's going to be my final answer. If you need to, go back and watch that again, and let me know if you have any questions at all. Okay? Let's do one more example, and then you'll be able to do the classwork on your own. So example number 2. Pam wants to use a savings account that has an interest rate of 3.2% compounded every month. If Pam initially deposits $2,350 into a savings account, write a formula to model how much money Pam will have at the end of each year. How much money will be in the savings account after 7 years? Okay, so we've got a lot of information here. I'm going to underline my question. First they say write a formula, and then I'm going to be asked to find how much money will be in the savings account after 7 years. Okay. Then I'm going to circle my numbers. So I see 3.2% compounded every month. Now I don't see a number here, but I know this is important because we want to know compounded every how often. This says every month. I'm going to box that. We'll come back to it and see what that means. If Pam initially deposits $2,350, 7 years. Okay, so we know we need to write a formula first. We know our formula is F equals P times 1 plus R over N to the N times T. Because we're using compound interest formula because we see this compounded every so often, but we want to write a formula for each year, okay? So it's a very subtle word, right? If we see compounded every so often, that's how we know we're using the compound interest formula. Okay, so let's start with P, because we know P is always an initial value. So it says if Pam initially deposits $2,350, that's my P. So I'll have F equals $2,350 times 1 plus. Now what's my rate? So this was my P value. My rate, we always look for the percentage, 2.3, and then divide that by 100. So 2.3 divided by 100 will be 0.032. That's my R. 0.032 all over my, now I need my N value, right? And the N value is the new thing. So in order to find N, I need to figure out the compounding period. So how often is interest compounded here? So it's compounded every month. So I'm going to say 1 month. Even though it doesn't say 1, we know if it's month singular, that's a 1. Okay, so then N will be 12 months divided by 1 month. And 12 divided by 1 is just 12. So that makes sense, right? 12 months are in a year. So if we compound every 1 month, that means we're compounding 12 times every year. So then my N value is 12. And I'm going to substitute 12 in wherever I see an N. And I'm going to write my T there. So I should have written that in black to be consistent. But this is going to be my formula in the box. That's my formula. So part 1 is done. We've written a formula. Now we want to figure out how much money will be in the account after 7 years. So 7 years, that's going to be my T value because that's time, right? So T is now 7. So if T equals 7, I'm going to substitute 7 into my formula. So F equals 2,350 times 1 plus 0.032 over 12 to the 12 times 7. Okay. Now, same thing we did in the first example. We're going to use order of operations. So parentheses first, then exponents, then multiplication. So F equals 2,350 times 1 plus, and I need to do 0.032 divided by 12. So I'm going to take out my calculator to do that. And I'll get 0.032 divided by 12 is 0.00266. 0.00266 or 27 to the 12 times 7. And I'm going to go up here again. F equals 2,350 times, and if I add 1, I'll have 1.00276 or 267 to the, and I can do 12 times 7 as well. And 12 times 7, if I clear this, 12 times 7 is 84. So then I'm going to have, I'm going to do this again, 0.032, just to be exact, divided by 12 to get my whole decimal here. This, I'm going to put this to the x to the y, 84th power, and I get an error because I forgot to add my 1. So I'm going to do it again, 0.032 divided by 12 plus 1, there we go, to the 84. Okay, there we go. Equals, so I'm going to have 2,350 times 1.25 approximately. Now I'm going to multiply that number here by 2,350. And my final value will be $2,939.14. Okay, so this is the most exact answer. You might get something different, right? If you used just 1.00267 to the 84th power, and then times 2350, right? So in this case, instead of 14 cents, I got 96 cents. So if you're off by a couple of cents when you complete the Google form and you look at your answers, don't worry if it's counted wrong, because I look back at each one and I will adjust your score for the Google form if you're off by a couple cents, so that you get full credit still. Okay? So this classwork is due Saturday, May 17th. It's a Google form. Make sure you're looking back at these examples. So the Google form problems will be very similar to what we just did. Of course, I have office hours every day at 11 a.m. to 12 p.m. I'm there the whole time. And you can text me if you need anything as well. Okay, have a great day and good luck with the work.